Hello guys, welcome to another video of Kubernetes. In today's video, we are going to discuss about Kubernetes deployments. Okay, I have already discussed some of the important Kubernetes concepts like Kubernetes pods, kubectl, and Kubernetes replica sets in my previous videos. So in this video, we will be discussing about Kubernetes deployment. We'll see what are the advantages of using it and how we can create and upgrade or check the status of the deployments in Kubernetes. So let's begin the video. Okay. So this is what Kubernetes deployment is. If this is your Kubernetes cluster and we have one worker node inside that worker node or even in multiple worker nodes, you can create one deployment and other things like your replica set and pods will be part of that deployment. Okay, so basically with one deployment you can create multiple pods and also the replica set with single deployment manifest file that is in YAML. Okay, and on top of that we will have one service. Using that service, users can access your pods and replica set along with the deployment in multiple worker nodes. Okay, so this is the architecture of Kubernetes deployment, you can say. Okay, we'll see what are the advantages and or what are the features of deployments. So the first one is to create a deployment to roll out a replica set. So if you also have to deploy a replica set, then you can create the deployment and you can you can define how many replica sets you want for the pods, and a replica set will be created inside the deployment. Okay, if you are creating one deployment will be created. Along with that, one replica set also will be created, and in that replica set you will have nodes. Suppose if you have given 10 nodes to have the in that replica set, 10 nodes will be created. Okay, we'll see this in just in few minutes. Okay, the second feature is you can update the deployment easily. So if you have to do something in your application, you can just update your YAML definition file, or you can run kubectl command to update the deployment easily. You can roll back the deployment easily. So whenever you create a deployment, or you just run kubectl apply hyphen deployment manifest file path, then Kubernetes will create a rollout history in the backend. Using that history, you will be able to roll back the deployment to the previous version. So suppose you deployed version 1.2 and you found some issues in that, then you can anytime go back and again roll your application back to 1.1 so that your users won't be affected by the new upgrade that has bug. Okay, you can scale the deployment if you have to scale it. You will have to, if you want to increase the pods, or you want to change the images from your container, or if you want to upgrade the application, or you just want to scale the basically your application, you can scale it using the deployments. You can pause and reuse the deployment. Okay, this means you can generally pause it. There is one kubectl command to pause the deployment and again resume the deployment. So suppose this we use pausing and reusing the deployment in a case whenever you need to do multiple things in Kubernetes. So suppose you have a or you are running a kubectl commands to make the changes in your Kubernetes. Okay, and you are changing the Kubernetes manifest file, and if you just change Kubernetes manifest file, it will automatically again make the change and it will restart your nodes. that means pods. Okay, so if you want to avoid this or you want to make multiple changes, you can just pause it, make all the changes whatever you want, and then again resume the deployment so that all the things will be changed at once, and your pods will be restarting only one time, not the multiple times. Okay, you can check the deployment status as well with the deployment. What is the status of deployment? How many pods are running, or how many pods are in waiting state to be created? You can see everything with deployment status command. Okay, you can clean up the deployments easily, or you can achieve the canary deployments as well using the deployments. Okay, so this is a YAML manifest file to create the deployment. Okay, so see, if you just have created this API version apps v1 deployment, kind deployment, metadata is name, this one, labels, you can provide the labels, and you will have to specify the specifications like we have already discussed. These are four important points. API version is mandatory, kind is mandatory, metadata is mandatory, and spec is mandatory. Okay, so here in the spec we have created one pods that is of nginx container. This will be created, these pods will be created, and we will be creating three replicas, and we are adding the selector as type as front end. So all the pods with the type front end as label will be part of this replica. Okay, and to create the deployment we simply run this command kubectl create hyphen f and deployment hyphen definition dot yaml. Okay, so this is my deployment manifest file. Once I run it, the deployment will be created, and if you run this kubectl get deployments command, you will get the deployment. Okay, how many pods are running, how many are available, and everything. If you just simply run kubectl get replica set, it will give you the replica set name as well. So this will be the naming convention will be the deployment name and hyphen. One random name will be assigned, random number will be there to differentiate with this with deployment. So this is your replica set name. Okay, whenever you create the deployment, replica set will also be created because we have given the replicas here as 3. Okay, and if you type kubectl get pods, you will get 3 pods which we are creating from here. Okay, and the pods naming convention will be my app hyphen deployment is the deployment name, 6795 this number is the replica set name, and after that this random number is the pod name. Okay, so this will be using this method you can even understand which pod is part of which replica set and which deployment. Okay, and if you type kubectl get all, this list all the resources which are created, like this is the deployment, this is the replica set, and these are the pods. Okay, so it will list all the resources which are created as part of the deployment. Okay, and now we'll see how rollout and versioning or update, you can say, basically happens in Kubernetes. Okay, so suppose you have this in revision 1, you have nginx 1.7.0 version in all the pods which you have in your Kubernetes cluster. Okay, and in revision 2 you want to upgrade it to 1.7.1 for all the pods inside your Kubernetes cluster. So for this, we generally use two types of rollout strategy in Kubernetes. Let me go again. So if you just type kubectl rollout status deployment name, it will just show you the status of the deployment, like how many replicas are available, how many replicas are still not being created. Once this is done, you will get successful message here in the printed out. Okay, if you run kubectl rollout history command and deployment name, you will get the history of your rollout, like whatever commands you have run and revision along with the revision details. So that if you have to roll back the deployment, you can just um, type the command for rollback and just type the revision. So it will be roll back to that revision. Okay, and here we have the deployment strategy. Like we have one deployment strategy just to recreate. So if you are selecting recreate as deployment strategy, your application will be down for some time, because in this strategy generally Kubernetes will remove all the pods at once, and again it will install the latest pods with the latest version inside your cluster. So for some time your application will be down, but this is not the recommended strategy, because in this case your application will be down at least for some seconds. So this is not recommended. And the second one is rolling update. Generally this is the default deployment strategy in Kubernetes. If you are not specifying any deployment strategy, this rolling update will be uh, the default. Okay, so in this Kubernetes updates your pods one by one. Okay, so suppose this is one pod, the first one, it will delete this pod and spin up another pod with the new version. Okay, again after that, once this is done, first pod is done, it will delete another pod and it will make this pod available again, and again this cycle will repeat. It will remove this pod and again it will spin up another pod with the latest version of your application. So in this way your application will also not go down, and again your application will also be updated with this rolling update deployment strategy. In any case, only one node will be down and rest of the only one pod will be down, and rest of the pods will always be available to support your application. Okay, that's why this is the default deployment strategy in Kubernetes. And generally most of the people and most of the organizations use this deployment strategy in their project. Okay, so if you see here, we initially we had created the deployment with just nginx 1.7.0 image. Now we are creating with 1.7.1 image. So this is our Kubernetes manifest file for deployment. Everything is same, we just have updated the image version here. Okay, to check the deployment strategy and how our deployment is happening with rolling update as deployment strategy. Okay, so once we made this change, again we will run the kubectl apply command -f, and this is my kubectl deployment definition.yaml. Okay, so new deployment has been configured, and you can see the deployment, my app deployment image is updated. You can also update this image with this command kubectl set image. This is the deployment name, and nginx is equal to, okay, nginx 1.9.1. Okay, So this way your image will be updated. And if you just type the kubectl describe deployment, this command is used to get the details of your deployment. I mean detailed uh, I mean you'll get the deployment uh, I mean details about your deployment in detail, okay, with this command. Once you type this, you can see the strategy type is recreate. Here we have selected the strategy type as recreate. And if you say see, in this case our replica sets, I mean all the pods are scaled up replica set to 5, scale down replica set to 0, scale up replica set to 5. So what this is doing, this is download, I mean deleting all the pods from the replica set. So initially we had, if in the first line you can see initially we had 5 pods in the replica set. Now it has removed it to 0. Okay. So in this period our application will be down. Again it will scale up our replica set to 5, then our application will be up. So even for a few seconds our application will go down in this scenario. Okay. But in case of rolling update, you can see strategy type as rolling update. And here replica sets, pods in the replica sets are being removed and added one by one. Okay, you can see scale up replica set, the here it is fine. Scale up replica set is 2 to 4 to 3 to 5, and finally down replica set my app deployment to 1. Okay, so it will uh, remove replica, sorry, pods in the replica set one by one, and again it will even add the pods one by one as well with the updated image. So in this case only one pod will be down at a time in our cluster. Okay, and the rest of the pods will be always available to support your application, and this will not make your application go down. Okay, this is how upgrade happens. Whenever you just update your deployment, another replica set will be created, and in replica set, in first replica set one pod will go down, and in the second one another pod will go up. Again in the second, again in the second, you can say in the second update, like in second time the second pod will go down and second pod in second replica set will go up. Same will be repeated. Third pod will go down and third pod will spin up here. Fourth one will go down and fourth one will be available here. Fifth one will be down and fifth one will be available here. So in any case you can see only one pod will be down. So suppose this is down, this 4 pod in one pod in here, that is 5 pods are always up. Okay, this we will be repeated. And if you type this kubectl get replicas, you'll see you have 0 pods in the previous replica set, and in the new replica sets you have now 5 of the pods are running, so that your application is now upgraded. Okay, and this is how you can roll back as well. If you want to roll back your application, you will have to roll back to your previous revision. Okay, so at this moment we have 0 replicas in my previous replica set. Okay, and once you run this command kubectl rollout undo this deployment name, this will undo the previous deployment. Okay, and it will roll back to the previous deployment name, or you can uh, roll you can roll out undo to the previous revision as well. Okay, so in this first diagram you can say we have 0 pods in the first one, the replica set starting with 67C. After running this command, you can see we have 0 pods in the second replica set, and in the 67C replica set we have 5 pods. So this way our application is now rollback. So you can just understand like how easy is to roll back your deployments in Kubernetes. Just by one command, you have all successfully rolled back your application to the previous version. Okay, and these are some of the commands generally we use in kubectl deployments. If you have to create the kubectl deployment, kubectl create -f. This command generally we use for most of the resources in Kubernetes. Even if you want to create pods or replica set, we can use kubectl create -f, and this is your manifest file name. You will have to provide it here. To get the deployment, type kubectl get deployments. It will list all the deployments which you have created in your cluster. You can run this command kubectl apply -f and your deployment definition file to update your deployment. Okay, so suppose you have to update the image name to something else in your Kubernetes deployment container. You can either run this first command kubectl apply -f by changing the image version in this file. Along with that, you can also run this kubectl set image deployment name and image name as well. If you want to know the status, you can type kubectl rollout status and deployment name. This will give you the status of the deployment. If you want to know the rollout history, you can run this command. By using this command, you can check all the Kubernetes history of your deployments, and even if you have to roll back the deployment to the previous version, you can check with this Kubernetes rollout history. And with a rollback command, kubectl rollout undo deployment name, you can roll back the applications to the previous version. Okay, you if you have to roll back the deployment to some particular revision, we have a command for that as well. Okay, so we have covered about deployments in this video. We have seen how we can create the deployments, how we can update the deployments, how we can check the status of the deployment, how we can roll back the deployment to the previous version in Kubernetes. That's it from this video. If you liked it, please like and subscribe my channel. If you are if you have any suggestions or feedback, please let me know in the comments. Thanks for watching.